Welcome back to Circuit Scoop. Today, we're diving into one of the most crucial parts of modern computing, the CPU or Central Processing Unit. Buckle up for a deep dive into what makes your computer and mobile devices so powerful. The CPU is often referred to as the brain of the computer. It performs the essential calculations and tasks that allow your system to run smoothly. From executing complex algorithms to handling simple arithmetic, the CPU is at the heart of it all. In this video, we'll explore the components, functions, and secrets behind the computing power of the CPU. Whether you're a tech enthusiast or just curious about what makes your devices tick, this deep dive will give you a comprehensive understanding of the CPU. So stay tuned and let's get started on this fascinating journey into the world of CPUs. The CPU is often called the brain of the computer. It's the central processing unit that handles all the instructions it receives from hardware and software running on the computer. Every action, calculation, and command goes through this single chip. It interprets and executes instructions from the computer's memory. But what's inside the CPU? It's a complex piece of technology with multiple components working together. Let's break it down component by component to understand how the CPU handles tasks and keeps our digital world running. We'll explore the arithmetic logic unit, control unit, and various registers that make up the CPU. By understanding these parts, we can appreciate the incredible efficiency and power of the CPU in managing complex operations seamlessly. First, we have the control unit, or CU. Think of it as the command center, orchestrating each step. When your computer receives an instruction, the CU decides how to handle it. It decodes the instruction, then directs the other components to execute it efficiently. The CU is crucial. It keeps all parts working in harmony. The CU fetches instructions from memory, decodes them, and then sends out signals to other parts of the CPU. It ensures that the arithmetic logic unit, ALU, and other components receive the right data at the right time. By managing the flow of data and instructions, the CU optimizes the performance and efficiency of the entire system. Without the CU, the CPU would be unable to function as a cohesive unit, leading to inefficiencies and errors. The control unit is truly the brain behind the brain, ensuring smooth and precise operations within your computer. Next, the arithmetic logic unit, or ALU. This is the part that does the heavy lifting with math and logic. Every time a program needs to calculate numbers, compare values, or make decisions, it's the ALU's job. For example, if you're adding two numbers or comparing values, the ALU gets it done in a flash. The ALU consists of multiple components, including adders, subtractors, and logic gates, which work together to perform complex operations. It can handle basic arithmetic operations like addition, subtraction, multiplication, and division, as well as logical operations such as AND, OR, and NOT. The ALU is crucial for the CPU's performance, as it directly impacts the speed and efficiency of data processing. Whether it's running a simple calculation or a complex algorithm, the ALU ensures that everything runs smoothly and efficiently. In essence, the ALU is the brain within the brain of your computer, making it an indispensable part of modern computing. Then we have registers. Think of these as tiny memory cells inside the CPU. They hold temporary data and instructions. Different registers have different jobs. For instance, the accumulator holds data for the ALU, and the program counter tracks the next instruction in line. Registers are critical because they provide the CPU with fast, immediate access to essential data. There are various types of registers, such as the instruction register, which holds the current instruction being executed, and the stack pointer, which keeps track of the call stack. The speed and efficiency of these registers are crucial for the overall performance of the CPU. Without registers, the CPU would be significantly slower, as it would have to fetch data from the main memory constantly. This immediate access to data is what makes modern CPUs incredibly fast and efficient. One key feature for CPU speed is the cache memory. Cache is a high-speed memory inside or near the CPU. It stores frequently accessed data so that the CPU doesn't have to go back to the main memory repeatedly. Cache is divided into levels, L1, L2, and sometimes L3, each with varying sizes and speeds. The faster the cache, the quicker the CPU can access critical information, boosting overall performance. L1 cache is the smallest and fastest, located directly on the CPU chip. L2 cache is larger but slightly slower, often found on the CPU chip or nearby. L3 cache, if present, is even larger and slower, shared among multiple CPU cores. Together, these cache levels significantly reduce the time the CPU spends waiting for data. This multi-level caching system is crucial for maintaining high processing speeds and efficiency. Now let's talk about buses. Buses are the communication pathways between the CPU and other computer parts. They are crucial for the efficient operation of a computer system. The data bus carries data, allowing the CPU to communicate with memory and other peripherals. The address bus carries memory locations, enabling the CPU to access specific data stored in memory. The control bus sends instructions and timing signals, coordinating the actions of the CPU and other components. Together, these buses ensure that data flows smoothly between the CPU and memory, maintaining the overall performance and stability of the computer system. Without these buses, the CPU would be unable to effectively communicate with other parts of the computer, leading to inefficiencies and potential system failures. Segment 7. CPU clock and timing. To keep everything in sync, CPUs have a clock. The clock is like a metronome, setting the pace for each component. Every tick triggers the CPU to perform a part of an operation. This clock speed, measured in gigahertz, determines how fast your CPU can process instructions, with each tick moving data from one step to the next in the processing chain. The clock cycle is the time between two ticks, and it's crucial for timing the operations. Proper timing ensures that all parts of the CPU work together seamlessly. The CPU pipeline relies on this clock to manage the flow of instructions efficiently. Even the CPU cache memory uses the clock to quickly access and store data. In essence, the CPU clock and timing are the heartbeat of your computer, ensuring everything runs smoothly and efficiently. In modern CPUs, multiple cores allow for parallel processing, meaning tasks can be split among different cores to increase efficiency. A quad-core CPU, for example, has 4 cores, each capable of handling its own set of tasks. Multicore processing is why today's devices can multitask so effectively. Unlike single-core processors, which handle one task at a time, multi-core processors can manage several tasks simultaneously without overheating. This is especially beneficial for high-performance tasks like gaming and video editing, where multiple cores can significantly reduce rendering times and improve overall performance. As technology advances, we can expect even more cores in future CPUs, further enhancing their capabilities. Every action in the CPU follows the instruction cycle: fetch, decode, execute, and store. First, the CPU fetches an instruction from memory. This involves retrieving the necessary data from the computer's RAM or cache. Then it decodes it in the control unit. The control unit interprets the instruction and prepares the necessary signals for the next steps. The ALU executes it, performing any necessary calculations or logical operations required by the instruction. Finally, it stores the result, writing the output back to memory or a register, ready for the next cycle. This cycle happens billions of times per second, enabling the CPU to perform complex tasks efficiently and rapidly. Together, these components, control unit, ALU, registers, cache, and buses, make up the CPU, giving it the power to process, calculate, and drive every program you use. Understanding these parts helps us appreciate just how powerful modern CPUs have become. Thanks for joining us on Circuit Scoop. If you enjoyed this breakdown and want more in-depth tech content, make sure to subscribe and turn on notifications. Stay tuned for our next video